Hey everyone, let's talk about the universe. I mean, the whole big story. Where did all this stuff come from? Stars, galaxies, us. Well, today we're going to dig into some wild research that says the secret might actually be right there in your morning coffee. No, I'm serious. That thing you do every morning, pouring cream into your coffee, it's not just about waking up. It's actually a tiny, perfect model of a huge cosmic puzzle. And I mean huge. It might just be the key to understanding why we're even here at all. Okay, so here's the big problem. There's this fundamental law of the universe, right? It says everything is supposed to get more and more disordered. It's all supposed to wind down into this final, kind of boring state called heat death. But if that's true, then how did we get all this? All this incredible, complicated stuff. Galaxies, stars, you and me. Think about it. The universe started out super simple, and we know it's going to end super simple. So how in the world did all this amazing complexity pop up in the middle? To even start to tackle that question, let's go right back to that coffee cup. It's going to be our little lab for figuring out the massive difference between something being disordered and something being, well, interesting. All right, first up, we got to talk about a concept called entropy. Don't worry, it's pretty simple. It's basically just a scientific way of measuring messiness. And the second law of thermodynamics is like the ultimate rule of the universe. Stuff just gets messier. That's it. You know how cream and coffee never unmix themselves, right? They only ever mix more. That one-way street towards messiness, that's entropy in action. Okay, so look at the very beginning. You've got your cream on top, your coffee on the bottom. It's super orderly, right? Very neat. In physics terms, that means it has low entropy or low disorder. But here's the thing. It's also really simple. You can describe it in 2 seconds. It's 2 layers. Now let's fast forward all the way to the end. Everything's totally mixed together. This is as messy as it can get. Maximum disorder, maximum entropy. But look at it again. It's also super simple visually. It's just beige. One boring color. Again, super easy to describe. But what about that moment in the middle? Look at that. You see all those incredible swirls and patterns? It's not neat and tidy, but it's not completely random and boring either. This right here is what we're talking about. This is complexity. This is the interesting part. So this is the key idea, the whole shebang. While the messiness, the entropy, just keeps going up, 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 the complexity does something totally different. It follows this arc. It starts low, shoots up to create all these amazing patterns, and then it falls back down to being simple again once everything is mixed. Okay, so that brings us to a really tough question. The word interesting is, well, it's a human feeling, right? It's subjective. So how on earth do you get a computer to measure it? How do you take that fuzzy idea and turn it into an actual number? Well, the scientists behind this paper came up with a really brilliant solution. They call it apparent complexity. And it's basically a super clever way to get a computer to see the same patterns that our own eyes just naturally find interesting and to separate those patterns from all the random messy noise. So here's how it works. It's kind of like a recipe. Step 1, you start with a really detailed image, down to every single particle. Step 2, you basically tell the computer to squint. You blur the image by lumping nearby pixels together into bigger blocks. And what this does is it gets rid of all the tiny random details and just leaves you with the big picture. And here's the magic trick. The more complicated that blurry, squinted image looks, the higher its apparent complexity score. And boom, that right there shows you the huge difference. If you look at the super detailed picture, you're measuring entropy, the total messiness. But if you look at the blurred, big picture version, you're measuring complexity, all those cool large-scale patterns. Okay, so now that they had a way to actually measure interestingness, it was time to put it to the test. And they did that with a really cool simulation. They basically created a little mini universe inside their computer. It was a simple grid where you have white particles for cream and black particles for coffee, and they just let them mix around based on some simple rules. They gave it a cool name too, the Coffee Automaton. So they ran this simulation thousands of times, and at every single step, they measured both the entropy and their new apparent complexity. And what they found? Well, it's the answer we've been looking for, and it all boils down to one single beautiful graph. And here it is. This is it. This one graph is pretty much the entire story. Okay, first, let's look at the blue line. That's entropy. And just like we'd expect from the laws of physics, it just goes up and up until it hits the max. Total messiness. No big shock there. But now, look at that green line. That's the complexity. And look what it does. It starts low, shoots up to a peak, and then falls right back down. That is it. That's the arc of interestingness we've been talking about. So let's break down what this curve actually means by looking at what the computer was seeing. Right at the beginning, that blurred big picture view is super simple. It's just a block of white and a block of black. You don't need much info to describe that. That's why the green line starts down low on the left. But then, right in the middle, the blurred image is gorgeous. It's full of structures and patterns. It takes way more information to describe this complicated picture. And that moment right there, that corresponds perfectly to the highest point of that green curve. That is peak complexity, peak interestingness. And then, of course, at the very end, that big picture view just smooths out again. It all becomes a simple, uniform gray. All those beautiful, complex patterns are gone. It's easy to describe again, and that's why the complexity curve drops right back down to the bottom. So, okay, a computer simulation of coffee. What does this actually have to do with us, with the universe? Well, the answer might be everything. This super simple model could be telling us the story of the entire cosmos, from beginning to end. The big idea here is that our whole universe might be on this exact same journey. It started in a really simple, low complexity state. It's destined to end in a really simple, low complexity state. And where are we? We're living right now in the middle of that incredible, complex arc. Let's map it out. The Big Bang, that was the very beginning of the curve. Super simple. The heat death of the universe, way off in the future, that's the end of the curve. Also super simple. But right now, today, we are right in that amazing, chaotic, fascinating middle part. The part where the universe is busy making things like stars and galaxies, and us. We might be living at the universe's peak of interestingness. So what does that make us? What is our entire existence, our civilization? Well, maybe we're just a temporary, beautiful pattern. We're like one of those swirls in the cosmic coffee cup, a brief, fleeting moment of maximum interestingness on this grand journey the universe is taking from simple to complex and back to simple again. Kind of makes you think, right? It's definitely something to ponder over your next cup of coffee.